Hi, my name is Rahmat. You can call me Rahmat. So welcome to the Tech Savvy. So today I want to share with you my final undergraduate thesis. So the title is called Analysis of Usage and Design of Change Data Capture for Implementing Multi-Master on RDBMS during Blue-Green Deployment. So this is my supervisor, Ms. Tricia Estelina Widakdo, ST-MSc, and the examiner was Mr. Ahmad Imam Kisti Jantoro, ST, MSc, PhD, along with Miss Dr. Yani Widiani, ST, MD. So the agenda was the first thing I want to talk about the introduction and then the general system description, and then the model mapping, implementations, and the evaluations. Also do some demo. So for the introductions, I want to talk about the blue-green deployment on database. So blue-green deployment is a deployment strategy by creating two separate but identical environments. The blue environment runs the current version of the application, and the green environment runs the new versions of the applications. And when doing a release, the traffic will be completely changed from the blue one to the green one and can be rolled back if there are problems or errors. But until the time of this research was written, no tool had been found that could synchronize the database during schema migration. So database schema migration is the process of changing the database schema, whether adding columns to the tables, changing table names, or dropping tables. This process is called change operations. There are several change operations. The following are the list of change operations for the traditional database schema by Dijkstra in 2021. So you can see there are a column, a dot of constraint, and so on and so forth. So I'm going to do next. So what is change data capture? CDC is a method for knowing and detecting data changes that occur when transactions occur in operational systems. Every time there is a data change event in a database, the changes will be captured, including create, update, and delete. So as you can see in the diagram, every create, update, delete will produce an event, and then using change data capture, it will be captured and then push it to the other application. The objective of this research is until the time of this research was written, no tools had been found that could synchronize the database during schema migration. Therefore, this final project aims to develop tools for carrying out blue-green deployment with two database versions running simultaneously and minimizing downtime when changing database schema. So this is the general system description. So this is blue-green deployment process on the database that I was proposing. So the first one is the database was doing some replications from the master to the replica. And then while we are stopping the database replications, all of the data changes was captured using CDC, and then the data record was put into a queue. So yeah, and while the database replication stop, it executes the database schema change executions like the query, for example, like alter table, drop column, and so on. And after the schema change execution was complete, all of the data from the old database and the queue, when the pre-login deployment data was transferred and then load to the new database using the tools that I'm working on. And when the blue-green deployments, the traffic was switched, so the data traffic is from the new one to the old one. If there's an error occurred, uh, we will terminate the new instance and the database will be rolled back. And if there's none, then terminate the old instance. So the error occurred is, yeah, we maximum amount of time of the error occurred was based on the agreement of the company. For example, I put 20 minutes to do the monitoring when the traffic was switched. Okay, next is this is the architecture diagram. So I was proposing using DBZium for the change data capture tools, and then Redis was the message queue, so that the data, so that the message queue was supposed to be a messaging between system. So the messaging between the DBZium and the tools I've been working on was Redis stream. So this is the model mapping. So there is a CLI which serves as the interface, and then the DDL executor to change the stop. This responsibility was to change to stop the replications, and then change the DDL schema and config for getting the use configurations input. CDC is a module function to receive data change from the database. Uh, it is supposed to be divisible in the CDC. And then data transformer is to transform data change from the CDC, and the query builder was the transport data record was uh, yeah yeah was changed into a database query so that it can be executed in the database when using query executor, and there is a report generator to generate the data application status. This detail of the detail change executor. Yeah, you can see the details on the report, and this is for the config. The mapping was on per table, and I'm doing some queries directly to the PostgreSQL database to get the primary key query. This is for the CDC module. So yeah, the config for the Redis stream was put into the Redis. So uh, Redis was used as a database also for the messaging. This for the data transformer. Yeah, basically just map the record. So this is the query builder. So change the data record into an SQL query. This is the query executor. I'm using a library in Golang to do the query to the database. This is the report generator. Yeah, it will generate a report using SQL query. So next part is the implementation. So for the development environment, I'm using a macOS Ventura 13.4.1 with processor of the Apple M1 and using Go 1.19 as the programming language. For the DBMS, I'm using PostgreSQL 14.7. For the streaming platform, I'm using Redis Stream, using Redis version 6, and the CDC tools, I use the Visuum Server version 2.3. And the container tools, I'm using OpStack because I think it is better to use OpStack rather than Docker Desktop to use Docker on Mac. And this is the configuration file format. So DDL transform, there's so actually I'm using a parser. So the thing that is cannot be parsed is the data type, if there is a modified data type. And the other one is all about the making connections, like the host of the database name, the username, and also the Redis. And I put the SQL file on the SQL file. This is the path for the SQL to do the parser. So for the evaluations, I'm using AWS. I'm using the operating system of the Kubernetes cluster was Amazon Linux 2, and using Kubernetes 1.27 with 2 CPU, 2 gigs of RAM. So this is the micro T3 micro. This is the lowest one. The management group was 3. So because it's supposed to be 3 because each AZ have their own instance. So yeah, this is for the micro also. and this new service is supposed to be released, and the region was US East 1 using Terraform 1.3.0. So why using infrastructure as code? So actually there's a good book to read by Keith Morris, which title is The Infrastructure as Code, Dynamic System for the Cloud Age. So one of the quotes is, the enabling idea of infrastructure as code is that systems and devices used to run software can be treated as if they themselves are software. So it's good to read. So yeah, if you have time and you are curious about the platform engineering, yeah, just read that book by Keith Morris. So this is the solution architecture. So actually, this architectural diagram was made using Java.io. So for the EKS itself, there is a ELB, Elastic Load Balancer, because in Kubernetes service, in EKS, the implementation was to use a load balancer. And you can see there are two database, which is primary and secondary one. And there's a cache, which is the Redis one. And actually, the node group was supposed to be spread on each AZ, but my current implementation didn't spread the nodes evenly. So the testing scenario is one of the testing scenario is the implementation of blue-green deployment. So I'm using a lot of Kubernetes manifest resource. So yeah, the purpose of this testing is to ensure that the tool can function optimally and effectively in supporting the blue-green deployment process in microservice. So in this, so later on I will show you the demo. So this is the result. Yeah. So I'm using K6. K6 is a tool that used as a load generator to create load on the applications API using on the application API. K6 acts as a load testing tool to perform constant requests at a rate of 10 requests per second on the application API. The final result of this test show that the success of these tools in carrying out blue-green deployment. So actually, the messaging was pretty bad because uh, it was supposed to be run on Bahasa, so I just used Google Translate. Just a disclaimer. The second is the functionality testing. So again, Kakas is tools, but Google Translate didn't know that Kakas is tools. Yeah, for the functional testing was using testing, yeah, test different development. So just use the test case. So the last is the performance testing. So the testing was using a BG bench for doing the benchmark. So the result of the testing was at a constant rate of 10 so 10 RPS, we have like a 99 percentile, so 99%. So I can assure you that all of the requests, 95% of the requests is below 1 second using this. But this is a really bad comparison if we are comparing it with the native PostgreSQL implementations of replications. Like I can see that 99% of the requests falls below 12 millisecond, and mine was 95% falls below 1 second. Yeah, I can say 99% falls under 1004 millisecond. Yep. So we're going to do a demo, but I will put it on the different video since it is like already past the 15 minutes. So thank you and see you in the next video. I'll stop the recording.